Good afternoon, everyone. My name is Stan Orchowski. I'm the Director of Research for the Justice Research and Statistics Association. It's my pleasure today to welcome you to this webinar on evaluating crime and justice policies and programs using matching to approximate randomized experiments. This is part of a series of webinars hosted by JRSA to promote the sharing of information by and among the state statistical analysis centers and other justice-related agencies. Before we proceed further, I want to thank our partners at the Bureau of Justice Statistics for making this series of webinars possible. Also want to cover a few logistical items. We'll be recording today's session for future playback. The link to the recording will be posted on the JRSA website and emailed to attendees. Today's webinar is being audiocast via the speakers on your computer. To access the audiocast, select Communicate, then Audio Stream from the WebEx application menu. If you do not have speakers or would prefer to use your phone, please use the number contained in your registration email or on the Event tab located on the top left-hand side of the screen. There are many people joining us today, so we've automatically muted the lines of participants to reduce background noise. If you are not a presenter, please keep your phone muted. If you have questions for the presenters, we encourage you to submit them using the chat feature on the right side of your screen. Please select Host and Presenter from the drop-down menu next to the text box. If you'd like to communicate with JRSA staff during the webinar, please submit your comment using the chat feature to Jason Trask or Host. The session is scheduled for an hour and 30 minutes and will end no later than 3:30 p.m. Eastern Time. If you have technical difficulties or get disconnected during the session, you can reconnect to the session using the same link that you initially used to join. You can also call WebEx technical support at 1-866-229-3239. Also, if you are listening to this with a group of people, if you could just please send an email to one of the staff folks, Jason Trask, and tell us how many people are listening with you. That'll give us a better count. Thank you. In the last 5 minutes of today's webinar, we'll ask you to complete a short survey. The information you provide will help us plan and improve future webinars and meet our reporting requirements. Full bios for all of the speakers are on JRSA's website, but I wanted to briefly introduce today's presenter to you. Our presenter today is Dr. William Bales of Florida State University's College of Criminology and Criminal Justice. Before he joined Florida State, Bill had a legitimate job. He was the Director of Research with the Florida Department of Corrections, where he was for a long time and worked in various other Florida state agencies. About 10 years ago, he, for some reason, decided to give all that up and join his alma mater, Florida State University, where he has taught all this time. Those of you know him and know him by reputation know that he's been a prolific researcher during that time, is published widely and in a variety of journals, and is an expert on criminal justice research and on statistical analysis in criminal justice, or at least I just made him that. He, as you know, had played an integral role in last season's championship, football championship, and will undoubtedly play an important role in what many are predicting apparently will be a repeat for this coming year. So, Bill, thank you very much for doing this, and I'm going to turn it over to you.
All right. Thank you, Stan. Welcome, everyone. As everyone, I'm sure, on this call knows, one of our primary important agenda items, if you will, in criminal justice research is looking at the impact of various types of policies and practices. And this is in general, but also amongst different types of individuals, whether or not certain strategies work for some people and they don't for others. And certainly an integral part of any of that type of research is trying to compare one or more outcomes across two or even possibly more groups of individuals, those that receive a treatment and those that do not, or those that can also obviously look at the duration of treatment, whether dosage matters. And again, as we all know, the epitome of research in this regard is the gold standard of random assignment, where we theoretically you randomly assign individuals to a control group who were not exposed to a treatment or intervention or to an experimental group. And this is, obviously this is done frequently in more the medical sciences, and the value of this type of research is that theoretically those two groups should be equivalent on all factors, excuse me, that might influence the outcome. So that, and unfortunately, in our field, there are numerous impediments to implementing random assignment, and so that's why it's used relatively rarely.
Bill, I apologize for interrupting you. Do you know how to move your slides? If not, we can move them for you, but if you don't know, I can also just tell you how to do it.
I'm sorry. I wasn't paying it. How's that?
Perfect, thanks.
I just moved it. Thank you.
All right, yep.
First time I've done this before. But yeah, there's clearly ethical issues when you randomly assign individuals who are under some type of control in terms of the law enforcement, judicial, or the correctional system. And so certainly agencies are not prone to allow researchers to come in and do random assignment. And also, clearly, conducting random assignment requires a tremendous amount of resources and commitment on the part of an agency. And I want to talk a little bit about one exception that I'm intimately familiar with is the Florida Department of Corrections decided back in 2003 to do a randomized experimental study of the effectiveness of their substance abuse treatment programs in prisons on post-release recidivism. And this is really an unprecedented study in the sense, for one reason, is because the secretary, who's the top person in that organization of 30,000 employees and $2 billion budget, decided that he wanted, in fact, he told the governor when he was offered the position that he was going to determine whether or not drug treatment in prisons really worked in terms of post-release outcomes, and that he knew that the only way to really answer that question was through random assignment. And it just so happens that was about the time I was transitioning to FSU, and one thing that they needed in that regard was to get an IRB approval. So they came to us to help them in terms of going through that process, and which was not an easy thing to do. But at the end of the day, they ended up, this was approved by the IRB at FSU, and over from January of 2004 to December 2006, the department, every inmate that came into prison, it was just over 100,000 people, were given the opportunity to consent to be in that experiment. And about right at 25% consented, and half of those were randomly assigned to treatment, or to the opportunity, I should say, for drug treatment, and the other half were denied treatment. And having seen this process unfold and tracked it over time, one thing I would say is clearly, again, this takes a tremendous amount of staff time, and again, commitment to do something like this. And but what I come away with that is, one thing is it clearly demonstrates that these kinds of studies are possible. And again, the main reason that study was originated and was completed was because it was someone in the agency that precipitated it and mandated it be done. It wouldn't have been done if researchers from anywhere came in and said, would you do this randomized experiment on drug treatment in prisons? I can't fathom that study would have been done. And it also shows that in some instances, practitioners see the value of randomized controlled experiments. In fact, we have a partnership grant through NIJ working with DOC, and one of the studies that we're conducting is analyzing that data from the random assignment process. Whoops, what happened? Stop. And one thing we're going to do that's germane to this conversation today is that we're going to look at the results of, or assess whether treatment works and who it works for, what types of treatment work, and so forth and so on post-release outcomes through the randomized experiment. But we're also going to apply multivariate methods, logistic regression, survival analysis, as well as the matching methods we're going to talk about today to these same populations. So at the end of the day, what I think will be incredibly valuable will be, at least I think this is the first time anybody's had the opportunity to compare a randomized experiment to these other multivariate and matching methods to determine, does the method matter, if that makes sense. So, maybe, of course, this would just be one experiment, but possibly we might find that matching methods, using just data that's available is just as good or almost as good as a randomized experiment. So, needless to say, we're fairly excited about this, and that process should be completed, or will be, by the end of this year. So that's something I wanted to kind of go off script and talk about a little bit. Let's see. So, but the fact is, most of our research has been, when we're trying to look at the effect of some intervention, historically anyways in our discipline, we've used some form of multivariate modeling technique, whether it be ordinary least square regression, logistic regression. I'm not keeping up on my slides, am I? All right. Wait, hold on. There we go. So, that's traditionally what we've done. And these methods are, there's certainly legitimate statistical methods to try and control for possibly, variables, indicators that are influencing the outcome. And at the end of the day, we're trying to identify what's the unique effect of our key independent / treatment variable. So again, in this drug treatment process, we'll be doing multivariate modeling to see whether drug treatment works, and the type of treatment, and the dosage of treatment, and obviously including covariates that we know historically from all the literature influences recidivism. And again, that's typically what we do in our discipline. So what are the disadvantages of these regression-based models that we've been using pretty much for decades? One problem is they represent, or the effect size that you determine from your intervention is kind of an average treatment effect amongst the targeted population, and again, controlling for other independent variables. And certainly, at the end of the day, for this kind of research, we want to convince policymakers, practitioners that something works or doesn't work, or it works for some individuals in some situations. And because we're not talking about theoretical testing at this stage. And so we certainly have to try and convince people that the analysis is valid. But trying to explain these kinds of methods is not very intuitive to most individuals. So if you use, effect sizes such as regression coefficients or odds ratios, those sort of things, for non-researchers, they're such as practitioners and policymakers, those are kinds of measures that are not that intuitive to them. So an advantage of these various types of matching methods that we'll talk about, which again are designed to really develop equivalent control in experimental groups except for the intervention, is it's relatively easy to explain that to a non-researcher. Of course, just as in these other traditional methods of analysis, the matching approaches are only or partially as good as the covariates, the measures that you have available to balance a comparability across the two groups. And also, in these matching methods, you're at the end of the day, you're going to end up with some subset of the total cases, depending on the matching algorithm. And so you're not really examining a true population. You're only keeping individuals in the control group and the experimental group that are either exactly the same on all of the measures that you have that are likely predictive of the outcome. So they're unlike randomization, you only have what you can observe, and whether or not the exclusion of other factors that may be influencing your outcome, independent of the intervention, that can be problematic from deriving true conclusions that yes, this intervention had this particular effect. So the three types of matching methods we're going to talk about include propensity score matching, precision matching, and one that's really just been developed and hasn't really been used in our field is called Coarsened Exact Matching. And propensity score matching was first developed by Rosenbaum and Rubin back in 1983, and it does provide the opportunity to compare outcomes across treatment and in a comparison group that are as close to equal as we can possibly get relative to the measures that we have available. And the goal here is to get as close to equal as possible between the two groups, again, based on the observable covariates. And so because of the fact that you might have a control group and an experimental group, that there's going to be some overlap across these various measures, and then you're going to have some level where there is no overlap. You typically you prefer or need to have as large of a sample as possible, which is not always the case. But what we try to do with these things is we try to replicate the conditions of a true experiment, so that theoretically the treatment variable can be treated as if it occurred at random, and that the samples in the two groups are homogeneous except for the treatment. And this kind of method has been around for a long time. It's certainly over the last decade or so, it's increased quite a bit more and become pretty much a well-established standard method in our field. And the basis of propensity score matching is deriving the probability of the group or individuals within your sample being in the treatment group based on, again, on what we can observe. And the propensity score is typically generated through a logistic regression model. So it's essentially taking all of the measures that you have on your individuals and predicting the likelihood of treatment. Because what you're trying to do is deal with the issue of selection bias, that there may be reasons why individuals end up treated versus non-treated. So you're trying to, if you will, simulate a randomized experiment, or at least to control for the biases that might exist for why individuals do get treatment versus not treatment. But again, we can only, unlike randomization, we can only match on what we observe, and we can try and minimize that selection bias into the experimental group as much as we can. So we're essentially deriving what's the probability of being treated, and so what we try to do is derive some kind of balance or equivalency in those two groups based on their likelihood of treatment. So we're trying to get homogeneous control in experimental groups so that we can somewhat approximate a randomized experiment and identify whether or not the treatment works and the extent to which it works. So what you're doing is you're essentially deriving equivalent groups based on the probability of treatment. And so theoretically, if you can achieve balance, then the exposure to treatment is random, and you therefore have a equivalent control and treatment groups. So they should be, from an observational perspective, those two groups should be identical. And there are a host of different types of propensity score matching. Pretty much anytime I've done this sort of thing on projects, and I've seen other people do it, is they'll try different ways of matching, and to make sure that the matching method doesn't influence the results themselves. And so one is what's called one-to-one nearest neighbor, and it basically identifies a person in the treatment group with a propensity score and then chooses a control case whose score is closest to that. And you can set calipers in terms of the distance between the p-scores across the two groups. And you can also use replacement or non-replacement of matched control groups to each treatment case. So that might be a situation where you don't have a large control group and you need to use repetitive cases that are the same across different treatment cases. Kernel matching is very similar to one-to-one nearest neighbor, but in that case, the difference between the cases in terms of their probability of treatment is a weight is derived, and that can be part of the analysis. Another one is one-to-one pair matching if the propensity scores are identical across the control and experimental groups for cases, then you keep those. That's a little more restrictive. And again, I think the most common thing is to try 2 or 3 different ways and make sure that those nuances don't influence the outcome. And I just want to give you one example of one study where I was involved with using PSM. This is with Dan Mears, who's on the faculty here. Also, we were looking at the effect of supermax incarceration on recidivism. And specifically, we wanted to know whether inmates exposed to supermax incarceration were more likely to recidivate. And also, there's certainly some theoretical reasons why exposure to supermax incarceration might result in greater likelihood of violent recidivism. And we had a couple of other questions that we addressed, but we didn't use matching in those particular questions. So this is one of the tables that is in that paper where we compare supermax and non-supermax inmates on a whole bunch on the covariates that we had available that typically have been found to influence recidivism. And if you look at the mean values for the supermax inmates on these covariates versus the unmatched sample, and you'll note there was 1,241 inmates that had supermax exposure and 57,245 that had no exposure. And you can see there's some pretty drastic, these two populations are fairly different. So, so the idea of using matching is to try and get an equivalent supermax and non-supermax population. But you can see supermax prisoners tend to be younger. They tend to have come into prison for violent crimes. They have more prior violent crimes, a lot more disciplinary infractions, not surprisingly, and so forth. So after the matching process through PSM, that's that last column to the right, those are the matched non-supermax inmates. And you can, when you compare the supermax and the non-supermax matched cases across the covariates, they're almost identical in their values. So we felt confident that we now had equivalent groups except for the treatment, if you will, of supermax incarceration. And one of the beauties of these kinds of matching techniques, unlike multivariate modeling, is showing the effect sizes are very straightforward. They're typically t-tests, so they're mean differences or percent differences, and any non-researcher, any policy or practitioner can understand these kinds of statistics, unlike odds ratios and so forth and so on. So you can see here, in terms of any recidivism, the matched case, if you look at the unmatched cases, right, supermax prisoners recidivated 12.2% more than non-supermax prisoners. After the matching process and getting equivalence in these two groups, the difference was only 1.4%, and it was not significant statistically. And that was true also for property and drug recidivism. For violent recidivism, we found a significant effect statistically, but with the matched group, it was only 3.7% higher amongst the supermax inmates. So not a large substantive effect, but there was an effect. But again, I believe one thing that this table demonstrates is the ease with which almost anyone can understand and interpret the findings. Okay, I'm going to turn now to precision or exact matching. And this is probably conceptually what a lot of people think of when they think of, matching two groups, a control group and an experimental group, is you look at people who look exactly the same one's in the control group, one's in the experimental group on some range of indicators. And again, this is actually precision matching has been around for many, many decades. It hasn't been used a lot in our field. In fact, kind of this is somewhat anecdotal, where I got interested in this kind of research was I read a paper by Nagin, Cullen, and Johnson, 2009 paper, in which it's a really good paper. What they're looking at is all the literature related to what's the effect of imprisonment on outcomes and post-release outcomes. And so they scoured all the literature throughout the world about whether or not the prison experience does it result in a deterrent effect, i.e. less crime because of incarceration? Is it a null effect, it has no effect, or does it have a brutalizing effect? It actually exacerbates the level of recidivism. And there are hundreds of studies out there, and one thing they did is they looked at these studies in three groups. One was if they used regression-based methods, and second is if they used matching methods, the kinds that we're talking about today, or they use some kind of experimental approach. And what was interesting was the fact that almost all of these studies were regression-based, but they made the argument that the matching method has a lot of certainly positive aspects to it. And so I started thinking about this, and I had a data set of people released from prison in Florida and thought, well, shoot, I could analyze that data using regression-based as well as different matching techniques, PSM and precision matching, to find out, do the results change? Does the method matter, essentially? And so I recruited Alex Picaro, and so we ended up publishing from that. And one thing we actually found was that the method, at the end of the day, the results, the conclusions, if you will, about the effect of imprisonment really didn't change a lot across those methods, whether it be multivariate or propensity score matching or exact matching, which was somewhat surprising. But what it told us, number one, is that the science that we have out there that's all multivariate based is maybe pretty good. I mean, based on the fact that we can't do random assignment, it appears to be consistent, at least, with the matching techniques. Anyways, that's an aside. Back to the precision matching is, again, we use this because we can't randomly assign people to intervention, typically, to an intervention due to ethical and practical constraints. And this is essentially where it's not really that statistical. It's a matter of building a data set of control and experimental cases that look exactly the same on all the variables, measures that you have available that may influence the outcome. And according to Nagin, and this is in that same article I talked about, he said exact matching is the surest way of accounting for a variable that may somehow be biasing results. And the next best thing is random assignment. The only, and he makes a big issue of the age, that age is such a strong predictor of recidivism that one of the problems with exact matching is that you end up losing so many cases that he calls it the curse of dimensionality. And certainly the more variables you have to match on across the two groups, and to the extent that your measures are continuous measures, it's difficult to retain an adequate number of cases at the end of the day to match, to analyze and compare the outcomes on. And so again, he talks about this tyranny of dimensionality, which certainly is a case, is an issue, and that's one thing with precision matching. You really need, typically you need a lot of cases to do this, because unless by chance your control and experimental group happen to be very similar on, the key predictors of your outcome, which is not very common, you're going to end up with a fairly small subset of your total. And also, again, if you're using measures that are continuous, like age or prior record, those are even more problematic. And oftentimes you have to revert to grouping those into some kind of ranges, which loses more precision in terms of your measures. So that's just something one has to account for. And there are kind of two ways to do precision matching. And this is the way I did it in that paper with the Caro, which was somewhat not clunky, but difficult. Essentially what you have to do is, and you can do this in SPSS or SAS or Stata, is you can identify the variables that you want to match on. Okay, maybe you have gender, race, age, current offense, whatever it happens to be. If you're doing recidivism, for example, and what you do is you want to take your control cases and match those to the comparison or the treatment group that are the same. And the way I did that in this particular case, and we'll see later with this newer technique, CEM, this is not necessary, but you can literally take those variables, make them character variables, and then concatenate them into one variable, and take your control group and your experimental group, treatment group, as two different data sets, and then match based on that concatenated variable. So at the end of the day, you'll end up with a data set where they look exactly the same on whatever number of covariates you have. And so the only difference between those two is obviously the outcome of interest, and again, just a paired t-test will tell you if there's differences in the outcomes across those two groups. And in that paper also, what we did was we looked at the issue of, well, what if you're controlling in this fashion using only 5 predictor variables, or 6 or 10 or 12? Does that influence the outcome? Okay. And from that paper here, you can see in this slide the ones that where there's no matching done, the difference between the prison cases and CC is community control, which is essentially house arrest. And you can see the prison cases, 79,000, the CC cases, 65,000, that there's fairly significant differences in those groups relative to gender and race, age, offense type, and so forth. So there's clearly, or if you look at something like the average prior prisons, 1.25 in the prison group and 0.41 in the CC group. So clearly these groups are qualitatively very different on most of these measures that we know influence recidivism. But once I did the precision matching, we ended up with 18,712 cases, 9356 in each group, and they look exactly the same. They're different individuals, but they are, by definition, equivalent. And this is just one of the tables from this paper, based on this matching, precision matching. And the other thing we did is you can see in the left-hand column, first, the no matched cases, and then we developed various matching, not algorithms, but just the variables that we included in the matching. Because one thing that Nagin et al. Said that if you're going to look at recidivism and the effect of incarceration, the kind of the 5 main variables is that matching 1 underneath the table: sex, race, age, current offense, and prior conviction. So we started with that one, but then did precision matching, adding more and more covariates to the analysis. And so you can see there are, when there's no matching, for example, to make this simple, the recidivism within 1 year, the rate was 11.7%. The first matching method, the difference is only 1.9%. But it does vary based on, when you go down those rows, it varies based on the number of covariates that are controlled for through the precision matching process. And in this case, we did keep age as a continuous variable. But again, another reason for demonstrating this is that if you were presenting this to a group of, legislators or almost anybody, they could understand these effect sizes, if you will. Okay, the third type of method of matching is called Coarsened Exact Matching. And this is a very, very new alternative to precision matching or PSM, created by Icas et al. In 2011. And it's different in that it does two things. One is it does allow you to do precision matching or exact matching, and we'll see in a minute. It's very simple to do, and you don't have to do all this concatenation of character variables, and it's a mess. So see, if you want to do precision exact matching, we'll see it's almost ridiculously easy to do through CEM. But coarsening is really the process in which continuous, ordinal, or even categorical variables are segmented into a reduced set of strata. So continuous variables such as age, it puts them into discrete categories and reduces the dimensionality of the matching process, and you'll get more matches through that process. And so this technique, I think, is fairly transparent, because really the causal analysis is based only on the matched observations. At least to my knowledge, so because this technique is so new, it hasn't been applied to our discipline, but it has some fairly attractive features. It's a relatively straightforward application. I believe it's more straightforward than propensity score matching. Well, primarily, you don't have to go through all the balancing. Anybody that's done PSM, if you can't get balance between your control and experimental group, you have to either transform variables or truncate variables or eliminate variables before you can get a balance between the experimental and control groups, so that empirically they should be equivalent except for which group they are in. So that's one of the advantages of CEM. And it does require, at least it's more effective, more efficient in larger samples or populations. like any statistical method, but that's not to say you can't use smaller n sizes. And also the CEM calculates a multivariate imbalance statistic, L1 statistic, and it looks at or measures the overall between group imbalance. So you get a sense of the equivalency between your two groups in terms of the likelihood of being in treatment. And it also does it for each individual variable in your matching process. So you can, when you initially do this on a population, you might find that there are certain variables that just don't balance very well. You're not getting equivalency across your two groups. And also, again, just overall, you know whether or not you're getting equivalency between the two groups across all of the covariates. And some of the details here in terms of what the numbers mean. So it's fairly easy to examine the differences between matched and unmatched cases from a bivariable perspective and also overall. And here's some sample CEM code and this was just kind of similar to what Picaro and I did, looking at what's the effect of certain covariates on, this is a different study he and I did on whether or not people receive prison or non-prison. And this literally, instead of all that manual maturations of, of creating a control and experimental group that look exactly the same that I talked about before, this literally does the same thing. You just have to put that #0 in parentheses after each variable, and it's going to do precision or exact matching. And then you do a t-test, and those are the results. So it's quite efficient in that respect. And this is some sample code. If you can essentially let CEM determine the level of coarsening of the variables to reach optimal balance between the control and experimental groups. It makes that, I can't tell you how it does it, but it does try and optimize the balance across the two groups. And this is the code to do that. And again, one of the nice things, again, it's going to tell you if you have imbalance across any of those measures. But the other thing you can do is if you want to, because when you're doing it, when you're letting CEM do it, coarsen the data, something like age, for example, it's going to determine what kind of groupings will coarsen the data best. And so you don't have any control over that. But you might, in some situations, there may be certain groups of individuals that you want to be, or for a particular variable or variables that you want to have certain intervals considered across the two groups. So in this case, again, a fairly simple code that I basically said, well, age of sentencing, I want it to be 10 to 17, 18 to 21, et cetera, or prior prison commitments. I don't want to keep that as a continuous variable. I want it in these categories. And typically what you would do is then run a logistic model that includes, after coarsening, includes the weights that are derived. So kind of in general terms, some of the strengths and weaknesses of these different techniques. PSM certainly in studies with smaller n sizes, because CEM and exact matching typically require a larger number of cases. So that's certainly one of the advantages of PSM. One of the disadvantages, anybody that's done this, going through the whole balancing process and having to transform or truncate variables and possibly losing information and specificity in your measures, that's one of the disadvantages of PSM. In terms of exact matching, again, balancing isn't required. The coding is very simple, and it's extremely easy for non-researchers to understand what you've done, how you've done it, and what the results, the differences in percentages or means correspond to. But again, like coarsened matching, exact matching typically will require fairly large n sizes, unless you, especially with continuous variables like age or prior record, if you want to lose information and collapse those in some way, you can increase your n size, everything else being equal. But that is one disadvantage. But again, it's fairly simple to do, and it's intuitively understandable very easily by non-researchers. And the coarsened exact matching, again, it's relatively easy to use in terms of specifying the level of precision of matching you want to achieve, whether you want to be very conservative or you want to loosen up the level of precision. But again, just as in exact matching, it typically, depending on the variability in what you're measuring, it requires fairly large n sizes. So, these are just some references. This didn't go on the slide very well, but anyway, just some references if you're interested in some of these kinds of methods that you can have access to. I think I've said enough, Dan.
Thanks, Bill. Can you just, I'm going to ask you to just put that reference slide back up.
Oh, sure.
So that people can look at that
sure.
while I'm asking you some of these questions.
Okay.
I guess the one at the first one that's listed, is that the one that the table 7 that you showed came from?
Yes.
Okay.
Yeah.
All right. So I'm gonna just ask some of these questions here while people can copy down any of those references they're interested in, and
sure.
then I'm going to ask you to go back after that to that slide because there was a question about that one. Let me see here. Can you? First of all, can you address the coarsened exact matching? Do you know how easy or difficult it is to do that in the other packages like SAS and SPSS?
I don't know.
Okay.
I've only used it in Stata. Is the only package. I can check on that if you want, because we have those different packages. I'd be glad to do a little experiment if you want and send it to you.
All right, that'd be
but I don't know. I used to use SPSS years ago, but I moved in when I was at corrections. We went into SAS, and I became a SAS person. And at the university, it's a lot of Stata, so I've done a little bit of Stata. So I don't know.
Okay. Another question. How would you account for CEM weights and sampling weights if you were analyzing survey data?
In CEM?
Yeah, that's a hard question.
If you were, yeah, that is a hard question. I do not know. I so rarely deal with survey data. It's just not something I'm familiar with, working with. Pretty much all the data I work with is administrative data from corrections or law enforcement or courts. So I really don't know. I can, if any of these questions I can't answer, which again I have no problem saying I don't know, I'd be glad to ask around here and send you the answers too.
Okay.
If I can find them. Yeah.
Can you just go back now one slide, just one slide to the advantages, disadvantages thing? Thank you. Can you address, just I guess based on your experience, the way this question was asked is the ratio of treatment to available comparison pool participants that's needed for exact matching. But I guess what I'm wondering is, in general, you know, when we talk about, you know, requires large N sizes, I mean, just how, I mean, the ones that the example that you showed was pretty darn large compared to the number that you ended up with. So do you have any guidance for folks on, based on your experience, on how large that's going to need to be?
I've never seen anything in the literature that says, you know, you have to have X, you know, minimum number of cases. Because again, it's so much, it is dependent upon the number of variables you're matching on and the measurement of those variables in terms of whether they're dichotomous or categorical or interval. As you get into interval variables, you need larger and larger, you know, numbers of cases to get an adequate number of matches by definition. Depending on the homogeneity of your particular group, right? When you're talking about, for example, people being sentenced to prison, there's a lot of variation in their prior record, their age, et cetera, et cetera. So I don't think there's no real rule on that, Stan, or that I'm aware of. Fortunately, at least here in Florida, we have so much data and so many cases. It's typically not a problem that we run into.
Do you have a sense of, just based on what you've done, like how many cases you've gone through or thrown out, or you know, to find some of those exact matches? I mean, or as the questioner said, some sense of the ratio. I mean, do you need to look at 5 cases to find 10 cases, 15 cases, 100 cases?
Well, and I hate to be nebulous and wishy-washy, but it's going to depend on the data that you have access to. I mean, certainly the work Picaro and I did, I mean, there was a huge attrition. You know, we ended up with typically, depending on the matching, you know, the matching criteria, less than 10% of the total of all the cases. Okay, let me, if I could comment on, not on that question, but something I should have said before, which I'm not sure that I did, was in that paper with Picaro, or 2 of them that we did, we also ran models the traditional way, using logistic, I think is what it was, and really the results based on logistic and these various matching methods, the conclusions were essentially the same, which I think buttresses the idea that, well, the traditional methods we've been using for decades, they probably tell the correct story. Again, but in terms of interpreting it and understanding it, it is not as straightforward, which I thought was maybe one of the more important findings, was that these our mathematical modeling is consistent with the matching relative to the conclusions drawn.
And do you have any, well, you mentioned, I was going to say this, but since you brought it up, you mentioned that was kind of surprising, and I find it kind of surprising too. And somebody had asked the question that I've always wondered as well, which is, you know, we were all taught when doing this that the matching is inferior, in part because there are just so many variables that that some of which are measured and some of which are unmeasured. And in fact, probably the ones that we measure are generally more trivial than the ones that we can't measure. And so the superiority of the RCT over the matching is that, in theory, it controls for all of those differences, both the ones that we might be able to measure, which we can control for using those regression techniques, but also all of the big unknowns that we never measured. And so it seems kind of surprising that the results would be similar. And I'm wondering if I'm wondering, A, what you think about that, and B, if you think that in the example of when we're looking at recidivism as a dependent variable, if in fact we've done enough research so that we actually have pretty well identified that set of covariates.
Mm-hmm. Well, in terms of the first question was
basically what are you? Yeah, I mean, how would that be?
Well, I mean, it tells me that the multivariate methods are controlling for those, predictors of the outcome pretty well relative to matching. That the findings don't change significantly. What was the second part of your question?
Well, just whether we have identified, in certain cases, with certain dependent variables like recidivism, whether we've identified, like in your example, when you keep adding covariates on, whether we've identified the right covariates well enough so that.
Right. Well, I think there's a cadre of covariates that we have pretty much coalesced on as being, consistent, significant predictors of recidivism. But my sense is there's probably a lot we haven't measured, and that's what the DOC randomization study I talked about earlier, that should answer that question, right? Mm-hmm. If we find that using traditional methods, whether it be matching or multivariate, that we find substance abuse reduces recidivism by 10%, but when you compare a randomized control and experimental group, it reduces it by 20%. And we're not going to know what we're missing. I guess that's what we haven't been able to measure that accounts for that, but at least it would give some indication whether the methods, and not just the statistical methods, but the measures themselves have been adequate in making conclusions about the effectiveness of treatment. Mm-hmm. At least to my knowledge, I don't think that's been done, primarily, obviously, because randomized experiments are so rare, and especially in this situation, one thing that is probably very unique is it's an entire correctional system, and the third or fourth largest in the country. It's not like the Wexler studies that was a randomized experiment. He says it is. They were in California. It was one men's treatment program in one prison, and so that particular study, we're talking about the entire system of corrections.
Yeah, I guess it would be interesting, and somebody has pointed that out here, to look at the comparison from the RCT and comparing those results to these other methods, like you did in the study, but adding in the actual results from the randomized control trial to see how they compare to the matching and the regression and so forth.
Right. Yeah. Yeah. And it's a substantial number of cases. Well, it's about 25,000, and half of those were assigned to the non-treatment group, and half were assigned to the treatment group. So we're not talking about small numbers by any stretch.
Okay. Can I get you to go backwards to that, the slide from your study with Picaro?
Sure.
And while you're doing that, I wanted to tell everyone who's still on the phone, we've gotten a couple of people who are out there who have told us that SAS macros exist to do the matching. There are some R package macros for that. In SPSS, it's available as an add-on module.
Okay.
So apparently there is some info. Yeah, there it is. Let me see now. Let me just switch back to my questions here. A couple of people wanted to know about, as you added covariates, the matched sample size increased and how that could be. I guess, like, for example, from match 1 to match 2 to match 3 to match 4.
Right. That's a very good question. I want to say I figured this out. That perplexed me also, Dan, when I did this, and it took me a while to figure out why that was the case. And I don't it's, that's 2 years ago. I can't remember what I did yesterday. No, I'm kidding. And I don't recall. Let's think. I can't bring it up. I don't know. But I am 99% sure we did have a logical explanation, that it wasn't an error, that it was real, but I can't remember I apologize for exactly what.
Okay. Another question. In the one-to-one nearest neighbor propensity score matching, how do you decide how to adjust the caliper to balance the precision with the matching, matching the minimum number of cases, or the maximum number of cases? Is there like a typical range for what that caliper should be, or guidance, I guess?
Yeah, not that I know of. I know oftentimes people will try different ones, different calipers. To my knowledge, there is no established standard, or it just depends on how conservative or liberal you want to be, right, in terms of the inclusion of matched cases.
Okay.
Yeah, I don't know of any set standard.
Okay. For those of you who are still on the phone, we are going to open up a little evaluation poll. So before you hang up, if you could please fill out the feedback form, I would appreciate it. There's a question about, could you explain a little bit about the specific known effect of eliminating data using exact matching? You mentioned, I think, the generalizability problem.
Mm-hmm.
I mean, has there been a lot of work on trying to figure out what specifically the effects are that you're aware of?
Not to my knowledge, Stan. There hasn't been. And maybe that's because that technique hasn't been used a lot, pretty infrequently in our field. Certainly PSM has been used much more. I don't recall anybody actually reporting that and trying to understand it and explain it.
Okay.
I haven't seen that.
Somebody else made the point, which I think is a good one, this idea of interactions among the variables of like the matching variables or the independent variables or the covariates in regression, and isn't that one of the advantages of being able to do this this sort of post hoc regression analysis stuff, is you can take into consideration the interactions among the covariates, and how does that play out in the propensity score or exact matching, or any of the matching, I guess, the interaction problem or issue?
Well, you really...
They're not my questions.
You don't really, you don't really have interactions, right? Because you're deriving equivalent groups based on all the permutations of your covariates, right? So it's not, there are no interaction terms as such, because obviously your purpose is to try and derive exact individuals based on predictors of your outcome, and then compare, the outcomes of the control and experimental groups that are equivalent at the end of the day. So I don't see where interaction terms would be applicable in that process.
Mm-hmm. Okay. Well, this is, I guess, kind of an interesting question. The whole question of sample size and matching, is it just a matter, if you have, I'm not quite sure how to ask the question, is there an optimal number of matches is what the question is, or is it just a matter of trying to find a match for every person in the treatment group?
Mm-hmm.
And,
yeah.
And I assume, and you don't want to throw away anybody in the treatment group.
Right. Yeah, preferably. Yeah, that's why the number of cases, well, primarily, or in the control group, is very large, right? So you don't, especially in exact matching, so you don't lose a substantial proportion of your experimental cases. But yeah, clearly that is an issue with especially precision matching. And I don't know that there's any, solution to that, unfortunately. But, depending on this, if you're dealing with administrative data nowadays, anyways, in so many instances, you end up with, tens or hundreds of thousands of records. You can be fairly successful in terms of these kind of matching techniques, but that's not, obviously that's not always the case at this point.
There is, I think you've answered this question pretty clearly about the RCTs and being the gold standard, but there is actually, a push to try to look at ways of doing randomized control trials more inexpensively. Mm-hmm. Looking at the use of, well, like in in the example that you cited, looking at the use of administrative data for the outcomes, like when you're looking at recidivism, for example, so that you don't need to be doing original data collection and so forth. Would you agree that would you agree that the RCTs are still the gold standard? And would you say that it's just what do you see are the resistances to implementing those, I guess, would be the question.
Mm-hmm. I think it's still the gold standard. Maybe over time, if there's multiple opportunities to compare random assignment to these other methods, like we're in the process of doing, if that shows over and over again that, well, even though we can't measure everything through administrative data or original data collection, that the results are essentially the same, then that would certainly be a good outcome, right? Because, I mean, the reality is with random assignment, and having worked in a correctional agency for 15 years, I can tell you, I mean, there were multiple times when I was at corrections in Florida here where people would ask, external researchers would propose a random experiment and it would get shut down immediately. Well, you can imagine, even in this case, and this was talked about just before I left with legal and so forth. We have a situation where an inmate comes in, they consent to be in the experiment, they have serious drug issues, and they're put into the control group, and they get out of prison and murder 3 people. So there's just a lot of liability, if you will. Certainly some pretty serious image problems if those sort of situations are explained by, well, we needed to find out if this treatment really worked, and the only way to do it is random assignment. That's pretty scary business for a correctional agency or any criminal justice agency. And again, just having witnessed it, the amount of time and money necessary to implement these kinds of random assignment processes is it's significant. And the fact that DOC here in Florida did it for 3 years, was pretty remarkable in my from my perspective, anyways. And plus, it has implications just in that particular situation. Here you have inmates who need treatment. They're in a facility where there is treatment, and they're denied that treatment because they consented and were put into the control group. That certainly, just from a operational perspective, that has consequences. So I think the conditions have to be perfect for those types of experiments to be implemented. And again, I think to the extent that they can originate from the agencies themselves, they're going to have a much better chance of being implemented and with number 1 and implemented with fidelity number 2. That's my understanding, or that's my impression.
Well, it certainly seems like these, certainly propensity score matching has gotten very, a lot of attention, in the last few years, and these other methods as well. I think that maybe particularly suited to the corrections example where you have a large amount of, potentially a large amount of data available to you. I know that you really do need to have a situation where there's a pretty big comparison group to draw from in order to be able to pull this off, because as you say, you may end up with only eliminating a good huge portion of that group. But in cases where it is relevant, these seem like useful tools that are good alternatives to the RCTs.
Right. Yeah. No, I think all these methods certainly have their pluses and minuses, and again, like I've said many times, I think in terms of the communication of the results to non-researchers, these kind of matching methods to me, are far superior to multivariate types of methods. When I was at corrections, I used to go to legislative meetings where researchers would come in and present their, OLS models to the legislators on some research, and they would pretty much walk out of the room just about. There was no way they were going to understand it. But they could understand the results of these various matching techniques.
Okay, well, I think we've covered most all the questions. Those of you on the phone, I appreciate you joining us. Don't forget that the session will be, and with the slides, will be on JRSA's website shortly. I want to thank Bill Bales, as well as all of you folks for joining us today. We hope that you enjoyed the presentation, and we hope that you will look for and join us on future webinars. Thanks again, and everybody have a great afternoon.
Thank you, Stan.
All right, bye now.